Hello students, how are you all? I hope you all are good. Now let's move on to our topic, that is motion, and this is the part 3 video. If you haven't seen the previous videos, go through it, then only watch this third part. In this video we are going to talk about the graphical analysis of motion or graphical representation of motion. So first of all, we need to talk about the distance time graph for uniform speed. Here we are going to first talk about the distance time graph for uniform speed. That means for uniform speed, what would be the graph, or how would a graph would be for the distance and time. So here it is written, when we are plotting the graph for the distance and time, there will be a straight line. Can you see over here? This is the time and this is the distance, and the graph formed over here for the uniform speed is a straight line. First of all, we need to know what is a uniform motion. A body has a uniform motion if it travels equal distance in equal intervals of time. For example, if a body moves equal distance means same distance in equal intervals of time. For example, in 1 hour 10 kilometer, in another 1 hour again 10 kilometer, again in one another hour again 10 kilometer. That means the body is moving in the same speed and it is covering the same distance as well. The distance time graph for a body having a uniform motion, it will be a straight line. Now let's move on to the graphical representation of the motion, and in this we are going to show the distance and time graph. Okay, in distance time graph, what does it show? It shows the change in the position of the body with the time. Okay, on the x-axis, okay, on the x-axis time is taken. X-axis means this one, okay, this one would be considered as the x-axis in which time is indicated, and on the y-axis, can you see here, on the y-axis the distance is taken. And when we get a straight line, can you see this red color one? When we get this straight line, this will be indicating the speed of the body. Okay, and whenever we plot a distance time graph for a uniform speed, that means it will be always in a straight line because it will travel equal distance in equal intervals of time. We can determine the speed of the body from the distance time graph, and here there is a formula to find out the speed, that is the speed of the object. V is denoted as the speed of the object. Can you understand? The V is denoted as the speed of the any kind of object, and here S is denoted as the distance of the object, and time is denoted as the time of the object. That means for the speed of the body between A and B and the distance is S1, S2 minus S1. Okay, here it is written wrong over here. It is S1. Okay, S2 minus S1, and the time is T2 minus T1. Okay, from the final time we will minus the initial time, then we will find out the speed of this object. Can you see this one? This is the formula. Whenever you need to find out the distance or the time, you need to minus the final distance divided by the initial distance, final time divided by the initial time. Once you calculate the speed, you will always find the linear or a straight line for the uniform speed of any kind of object, in which we are plotting the graph between the distance and time, and we will get a straight line. So here also you will find it as these are the times and these are the distances. Okay, you can see in 2 hours it traveled 100 kilometer, in 4 hours it traveled 200 kilometer, in 6 hours it traveled 300 kilometer, and in 8 hours it traveled 400 kilometers. So in this way, if you have to find out the distance and the timing, you just have to do means S2 minus S1. Here it is written X2 minus X1. Either you can write X2 minus X1, or either you can write S2 minus S1, and also you can do the T2 minus T1, and then you will get a straight line like this. Here also there is a neat graphical representation of uniform motion graph. In 1 hour 10 meter in 2 hour, 20 meter in 3 hour, 30 meter in 4 hour, 40 meters. That means the time interval is equal as well as the distance is also equal. Now let's talk about the distance time graph for the non-uniform speed. Okay, whenever you will plot the distance time graph for a non-uniform speed, you will always get a curved line. Can you see over here? The distance and time graph, if you will plot it, you will always get a curved line. Okay. Here is one example. You can see in 0 distance was traveled. In 2 seconds, 1 meter was traveled. In 4 seconds, 4 meter was traveled. In 6 seconds, 9 meter was traveled. Okay, so even though the time is same, I mean in equal intervals, but the distance is not equal. So that is why it would be called as the non-uniform motion. And in this way you can see this graph plotted according to 0, 0, in 2 only 1, in 4 only 4, then in 6 9. Can you see this one? This is called, when we are not getting a straight line, that means that is not a uniform motion. This is called as the non-uniform motion. So in this slide, again we have seen that the distance time graph. Okay, we have seen the distance time graph for the non-uniform motion, which is non-linear. That means it is not in straight line. Why? Because there is non-uniform speed of a body traveling unequal distance in equal intervals of time. Even though there were equal intervals of time, but it traveled different distances. So that is why we will always get a curved line in non-uniform motion. So that's it we studied today. Okay, we studied about the graphical representation of the uniform motion and non-uniform motion by doing it with the distance and time graph. Thank you, students.